Okay, so like I said, many of you are equipped to do the first assignment without any help, but some of you need some guidance, and especially those of you who did Comp 116, you haven't even seen Java. Okay, so what I'm going to do is try to kill two birds here. I'm going to give you a little bit of a lesson on scanning, which is going to be very simple for everybody. Okay, but I'm going to use that as a driving problem to introduce Java to you. Okay, and I'm not going to introduce Java to you formally. Okay, so it's like when you go to a foreign language class, you go to the first class and you're supposed to learn, the basics. But they just start talking to you in French or German, whatever, right? They just say, just talk, and you kind of get an idea. You know English, you know the context. Maybe you can go and answer someone. Okay? So we're going to do it like that. I'm just going to throw code at you and say, try to interpret yourself without giving you any formal definition and see what's going on. And most probably those of you who haven't seen Java also will be able to figure out what's going on. Okay? And I'll show you enough of Java to do the assignment. Okay? So again, those of you who are feeling very handicapped and say, look, what Java book can I buy and how much do I have to study here? Okay, I'm not letting you use the full power of Java, right, in this assignment. Okay? So, so you're not at a disadvantage, and hopefully you'll see. Okay? So with this example, I'll be also not only introducing you to Java, scanning, but also some abstract concepts. Okay? So we know what a problem is. That's what we're trying to solve when we write a computer program. We know what code is. Okay, that's what we write to solve the problem. Algorithm and representation. What might I mean by algorithm? And I'm sure every one of you has heard that term. So this is your chance to show off or to think a little bit. So what might I mean when I say an algorithm? Okay, a set of steps that you go through to get the result. Very good. So is the program an algorithm? Is the code an algorithm? No. His definition is what? Set of steps. Is code a set of steps or sequence of steps?
An equation?
An equation, you're saying an algorithm may be an equation?
Yeah,
so algorithms may involve equations, okay? But, typically it's more than an equation. If you're going to, the analogy people often use is a recipe, okay? So if you're cooking something, it'll be nice, there's a little equation there, but you have to go through a set of steps. And there's no result produced. Well, maybe there is a result, but that's sort of the value created. But, there are things called procedures and functions, and procedures don't return results, and functions return results. So equations might help you with functions, but they're not going to help you much with procedures, okay, unless some step in there. So, but going back to, the definition that we got, which I liked, a set of series of steps, is code an algorithm?
Wouldn't it be more of a language than an algorithm?
So code is written in some language. It's not a language, right? Equation is written in a language, which is a mathematical language. So yes, we will require a language that is probably different from what you're used to in ordinary life. Okay?
You can break code up into methods and classes and get into smaller steps. I guess that follows from saying, well, I want to start with this foundation, and I need to make it this and this.
So you can do stepwise. So is code an algorithm?
I think it can be if you want to code it like that, and it can be if you code it like that.
By definition, it's a set of steps to solve the problem. It solves the problem. Okay? So it is an algorithm. Now, it might be a very detailed, boring algorithm. When you tell a story or a joke, you can give, a long, what is called shaggy dog joke, or I forget what the right term is. But you can tell the joke with a lot of details that are not interesting, or you can get to the point, right? So the boring parts, you want to omit sometimes when you're going to be presenting the algorithm to somebody else. But what's boring, what's not boring, Some detail might be concept to somebody else. So code is absolutely an algorithm. But all code is each program is an algorithm, but each algorithm is not a program. And as you were indicating that when you write code writing using high-level steps, methods perhaps. Okay, and then maybe you in your algorithm you just deal with the method level and you never get into the implementation of the methods. That's also an algorithm that omits certain details. Okay, so the algorithm can be given in English, can be given graphically, can be given in code. They're all algorithms. You can talk of high-level algorithm, low-level algorithm, and code is the lowest of possible levels in an algorithm. Okay, so typically the reason why you guys thought that the code is not an algorithm is because you tend to, before you go to the code, you tend to go quote unquote the algorithm, the main points. Then you get to the details. Okay, often the algorithm is language independent. Okay, so it will work for Python, it will work for Java. It doesn't matter. So that's why the answer that look for code you have to know language, for algorithm you don't have to know language is true, but you have to know some language. Maybe it's graphical, maybe it's English. Okay, so we get an idea what algorithm is, and we're going to do the scanning problem by first giving an algorithm which is high level, graphical. Then we'll get to the code. Okay, and at the algorithm level, you Comp 116 students should not feel lost. Okay, and it's only at the code level that you'll learn something new. Okay, and because there is a separation, that's why you should feel confident that if you've done programming in any language, you'll be able to survive here, because the important points are in the algorithm. The unimportant, boring things are in the code. Okay, when algorithm is not the code. Representation. Anybody heard that term in your course before? Nobody? Yeah.
It's talking about using comments in your code to tell other people how you're doing it.
Using comments to tell, that's documentation. Representation. None of these books you studied had representation? Yeah.
It's going to be different types that determine what something is represented as.
Okay, so if I'm going to count numbers, should I make the number so we won't make it a string because to inefficient we'll make it some kind of number type, and we might have, do we have a choice in the various number types? You can use a few number of bits, we can use a large number of bits, we can use a very long number of bits. Okay, and you have the types in Java: short, int, long. Okay, so that's some choice we have to make. So often we first come up with the algorithm where we don't talk about representation. It's a number. Then we go to the next step and say, okay, how are we going to store the number, data structure, or the representation? Then we get to the code. Okay, so that's exactly what we'll do in this class. We'll come up with the algorithm, then we'll come up with the data structures or the representation, and then we'll come to the code. Okay. Okay. Scanning. So we use the word scanning a lot. Okay. We might be scanning images for text. We might be, in ordinary life, we might be scanning frequencies. We might not do it automatically. Our devices might do that for us, or we might actually be flipping through them. Scanning a sentence to find the words in it. Okay, and a computer program, every time you write a program, the compiler has to do a lot of scanning. In fact, most of the time of the compiler goes in scanning. Okay, that's why one of the constraints I put on you is that please do not scan the string more than once. Okay, because that scanning cost is the dominating cost. Okay, and when you're scanning a program, what are you doing? You're saying, what are the various names you define? What are the various identifiers? Names for things that identify, names that identify various concepts. What are the operators, plus, minus, you've had? Okay, so what are the numbers there? So that's what you're doing. So I've kind of told you what scanning is by example. Anybody want to try to give a little formal definition of what scanning might mean? Yeah.
Integrating through the components of some kind of range or group, like a string or a list of frequencies.
Okay.
Or identifiable objects being used. Those are the tokens.
Very good. Lovely. Okay. So you're going through some sequence. It's ordered. of some entities, and you're finding some objects in them, which you're calling tokens. So given that there's a sequence of some unit, can you be a little bit more specific about what these objects might be? Sorry? Useful things. But in terms of just, given that that's a sequence, if I have a sequence of 8 characters, could the token be the first, 7th, and 8th character? Could a single token be that?
You can do whatever you made it.
Okay, so if you do that, then that's not quite scanning. Scanning I'm kind of implying that it's not. And if it's not, then each token would be a subsequence within that sequence. Bunch of consecutive units in that sequence. Okay, that's what it is. And the token could be of length 1 or length multiple. There are seats in front. You don't have to stand in the back. Okay. We're going to see that definition in the next slide. But before we go to that, let's just go do this little simple problem. Okay. How many of you have used the command line in your operating system? Okay, good. Lots of you. Excellent. So can you try to figure out what's going on here? Can we interpret, what I've just typed in and what came out, what's going on, and what this might have to do with scanning?
Like kind of scan string for things letters.
Okay, so what you're doing is you're scanning the string for the uppercase letters, and the tokens here are now J, F, and K. Each one of them is exactly 1 character long. Makes life easy for me. Your assignment is a little harder, and then the project is even harder. Okay, now can we just go and look, but that's semantics. You just told me what this is doing. Let's just go through this syntactically. What is this word Java here? What's it denoting? The Java compiler? Firstly, this is a command line. Let's abstract this out. The first word you type in a command line is typically what? Some program in the operating system. And the rest of the words that occur are called what? Arguments to the program that you ran in the first one. Very good. Okay? So this is some program so what's your name? Christian? Okay, which Christian said was a Java compiler. Okay, we know the word Java exists here. We know Java comes with a compiler, so that's an excellent guess. Okay? And what is the first, so what is the second argument here? It's a program. Excellent. So this is a program and this is a program. That's kind of interesting. To this guy, this is just an argument. But to us, this is a program we wrote. Okay, so that makes sense. A compiler is a program that takes as an argument another program. It compiles it. So that it seems he was right. Okay, so we go and take the Java, whatever it is, program, and to it we give another program. And what is John F. Kennedy now? This is the third argument to. This is the second argument to the Java program, and it's an argument to the second program. It's the first argument of our program, and the second argument of the Java program. Okay. Now the compiler compiles code. We know that. Does the compiler why does the compiler have to? And what does the compiler produce? Executable code. You will pass argument to executable code or to the source code? Executable. So maybe I was right in questioning whether this is a Java compiler. So if it's not the Java compiler, what other thing comes with Java? Java interpreter. Okay. So at this point, this program has been compiled, and this program in Java happens to be called a class. Okay. So this is actually a class that has been compiled by a Java compiler, and what might be the name of that program? Eclipse is a programming environment. it has the compiler in it. So you kind of think that it's got a compiler in it. It's got an interpreter also in it. It's all linked to it. Okay?
It's a Java virtual machine.
So this is the Java virtual machine, right? This is the Java interpreter. Absolutely. And what's the Java compiler called? What might you call it if you had to give it a name? Very good. If you were a lazy guy, don't want to type Java compiler, what might you call it? Java C. Okay? You don't see that, it's under the hood, but it's something I've already done before. Okay? So this is the Java, so let's see. So this is a program name. This is the first argument or option to the program. And what we see below is the output. Okay? And the first thing is the Java interpreter. And the Java interpreter, just like we had our interpreter, remember? We wrote our interpreter was doing sort of the compilation also, the scanning, everything on the fly. That's inefficient. I told you scanning is very costly. If I have to go and scan the program each time, my programs will be even slower than they are today. Okay? So we first compile it in some compact form, then we interpret it. And so those of you how many of you have seen some C-based language, C, C++? Did you guys have an interpreter there? No. You just said compile, and then out came a file name, and that file name was given as the first argument in your command line. Here we go and have an interpreter also, and in Java we have an interpreter because it's a little louder. It's a higher level language. That is actually normally true, that some of the high-level languages are languages like Prolog and Prolog especially, Scheme also to some degree. So they come with interpreters. So that's a very good intuition. But you can have interpreters for very low-level languages too. If you saw the language we had in the Monty Python demo, that was a very low-level language compared to Java. But we still interpreted it. What's the property of Java that has made it so popular? Objects, but C++ also has objects. C# has objects. Virtual machine, and virtual machine is important because platform independent. Okay, so the whole idea is that we'll write a compiler that compiles the code into some form that is machine independent. And then for each machine, we'll write a virtual machine or an interpreter that will go and interpret it. Okay? And was Java the first language that came up with this idea, you think? So a long time ago, there was a very smart guy from Switzerland called Nikolaus Wirth, who invented a language you might have heard of called Pascal. And at that time, IBM was the big company and still is, and they were dominating with their languages. And he wanted to spread the word with his language. So he said, I want it to be available everywhere. I know people won't write compilers for it. So I will write an interpreter for it and generate what he called P code, Pascal code. And then people just went and wrote interpreters for that, and it caught on. It replaced all the languages IBM had. So that was the idea. That's where this idea first came about, and Java adopted that idea for Java, for object-oriented language. Okay. Okay. So I thought I'd change the slide here. Okay. Sorry. So we're going to talk about the algorithm right now, and I'm just going to repeat what I said earlier. It's a solution to a problem, can be in any language, okay? And we're going to go and look at an algorithm for this problem, and let's go and first define the problem a little more precisely, okay? So if you're going to define scanning involves a sequence of units. Characters, strings, whatever you might call it. And it involves finding subsequences in them, which we'll call tokens. Okay? And not every unit in that stream is going to be part of some token. Okay? Typically, the stuff that is not part of a token is called white space, because typically it's white space. But in our problem, even the lowercase letters are white spaces, if you will. They are things to be ignored. Okay? So we'll ignore certain things, and to make your first assignment easy, we made sure that the white space is exactly one unit, okay, just to make it easy as for the regular credit. So there's an input stream or sequence, and there's an there's a stream that you create from it, which is a token stream. And then you can process the token stream even further, and that's what the parser does typically. Okay, the scanner will create the tokens, and the parser will follow the syntax rules. So in John F. Kennedy here, our tokens are J, F, and K, and everything else is a non-token character. Okay? So that's a problem. That's what we have to solve. Now, give me an algorithm for it. Look at O. We know it's not uppercase, so we do nothing. We keep increasing the marker. We get F. Keep increasing. K. Now what happens? We don't know what's ahead. So we have to go till the end and stop at that point. Okay? Okay, that's the algorithm. Not very hard. Okay? Doesn't matter whether you've taken 116, 110, whatever. Okay, question? Okay. So now we get to representation. What are the things we have to represent at him? Okay, by the way, so this is the scanning algorithm for this particular problem. For your assignment, I've got a little link from your home page that will give you the algorithm for essentially, your problem there graphically. And that's okay. You can go and look at that. You don't need to at all. But if you want. You can. So now let's go and figure out the various data types that we might require here. So how might we represent the stream, John F. Kennedy? As what type? String? Did you guys learn strings in 116?
I didn't, I'm old, I didn't take it, no, seriously.
Okay, somebody, I thought you were. So were you 116 students? You did strings? Oh, excellent. I have to worry less. Okay? This. I can just say this. If next letter is greater than equal to capital A, and next letter is less than equal to Z, then it's a Okay, so I want to again make a distinction between getting something from as a program argument and reading something from the console. Okay, now we are going to read. Okay, great. So the class is managed just not by me, but by these guys also. In fact, you'll be seeing more of them outside class than me in many ways. They'll be doing the recitation, they'll be having office hours, they'll be doing all the grading, and they'll be doing a few other tasks also, such as, well, I won't get into those right now. Okay, so thank you. Okay, any questions? So I know after I finish class, there's a long line of you who come forms and want to ask specific questions. And trust me, if you have a question, there's probably 10 other people who have the same question. Okay? And the whole idea here is that, we can't really, it's not very efficient to give individual answers. So don't feel shy about asking questions in public. The more shy you feel, the less you'll learn. So you've got to have a little bit of a thick skin or to really learn, I think, anything. So whatever question you were going to come ask me later, you want to ask right now? Yes, good.
Is the rubric available for the first assignment?
Okay, guys, so the rubric will be available when?
Yeah, I posted it on Piazza last night.
Okay, so it's posted on Piazza. If anybody is not enrolled in Piazza, please do. That will be the mechanism for making announcements. Okay? And so I suggested one correction today.
Yes.
So just keep looking at the rubric might change, and you'll get notifications about changes too. Okay. In fact, that's what we'll do. We'll put a draft one as soon as possible, so that you have some idea, and then as we discuss it more and as we get feedback, we'll change. In fact, the last time I taught this course, I had students propose rubrics. And so that was good because, you guys really know how much work was involved. And 2 or 3 students got into it. Nobody else did, so we kind of gave up on that idea. But if you want to propose rubrics or propose, say, look, this seems disproportionate, please do. Because it's sometimes it's very hard for us to put ourselves in your places, okay, and know how much, how difficult it is for you, what may be easy for us, okay. So things might evolve, and by Wednesday midnight for sure, we'll by Wednesday morning, hopefully in general, it'll be cast in stone. Okay, so that we can submit early. Other questions? Yes.
If you start a line with a period and then have numbers after it, should it just terminate or should it still penetrate?
What do you think?
Should it just terminate?
Up to you. Okay, that's an error condition. And error conditions are up to you. I say it's a line that contains exactly one period. Okay, when it's not that, whatever is convenient. Okay, error reporting is such a difficult task. I was going to say pain, and that's why people don't do a very good job of it. Even in industry code, you might have seen blue screens just because people don't do all the error checking, and that's why I didn't make it mandatory to do error checking. And as you find time to do things, go ahead and add these things because they're very important. Okay, from a user's point of view, they're very important. Even from a programmer's point of view, from another programmer's point of view, it's important to know what the previous programmer did by just looking at the error codes. Yeah.
For the screenshot, we just submit one or we submit as many test cases as possible.
So what do I say in the assignment? Sorry?
The rubric just says.
No, what do I say in the assignment? Okay, so you have to read, some of these things you have to read carefully. And I think what I say is, and the thing is that I'll often ask you, what do I say in the assignment? Because I have forgotten what I said in the assignment. And I don't want to say something conflicting. Okay, so if somebody says, is this allowed, I always say, go look at the assignment. Okay, firstly, I want you to read the assignment. I don't want you to come individually, each one of you, and say, is this in the assignment? When you could have read it. So I think what I say is, anybody remember what I say in the assignment? About how many screenshots to submit? Yeah.
You said to submit how many screenshots to prove every aspect of your program. So if you have some error handling, make sure your screenshot
Okay.
shows the error.
I think he's phrased it better than I did in the assignment, that you show as many assignments as are needed to show the functionality you've implemented. Okay? So if you are handling period, in the error case, in which there's a period followed by a number, show off that feature and say, look, I handled this too. Okay? And the TAs may or may not run your program. Okay, so it should be possible for them to just look at the screenshots and know what you've implemented. And then they can just look at the code and say, okay, does the code seem consistent with the screenshots? Okay?
On the method that we could use, which is just in the assignment, one of them is next string.
Oh, sorry, what string?
Next string.
Yeah, I think I changed it.
I don't think it exists.
Yeah, there was a whole Piazza discussion on this, and if you look at the assignment, it's corrected to next line. Okay? Yeah. How do you fill the rubric? So when you see the rubric and there's been a message there, just go look at the rubric. There'll be a table there where it says, tell us what features you've implemented. And here's the set of features. Here are the things that we are going to grade you on. And tell us whether you implemented that feature or not. No. So when you will submit the rubric as part in Sakai. You will create a copy of the rubric, you'll fill it up, and when you go and upload your assignment directory, you'll also upload the rubric and the screenshots. So have you ever done a Sakai upload? I haven't, so I'm actually, you guys know better than me, but isn't there a way to go and upload files and directories? There is. Okay? So there's a way to upload a file in a directory, so I'm not sure.
Should rubric be like files, or can we just put it in like the section where we just like
A separate file. Okay? That's the easiest. You get a file, you change the file, you submit the file. Okay? At some point, we might have an automatic grading system working, where we'll tell you exactly, we might constrain a little bit more how you upload things. Okay? Other things? How many of you are still waiting to get in? Wonderful. Nobody. Okay, great. Okay. So I still passed the attendance sheet around just in case there were more people waiting because, wanted to see who's in, who's not in. And I might take, I always thought taking attendance would be very disruptive. It doesn't seem that disruptive to me. I don't even notice you guys for putting your names in. So we might do this more frequently. As a student, I never liked the idea of a professor enforcing attendance. But there's enough research to show that your grades are very strongly correlated with your attendance in class. Okay? And especially in my course, where all this material is available outside, you might be tempted to think that you can always look at this later. I think I mentioned this earlier. And that later time never occurs because of other deadlines. So this is to make sure that you're sort of a captive audience here, learning things. Okay. So if I see the class thinning down, if I see, people that stop coming, I might start taking attendance sporadically. Okay? Okay, so we were looking at this code, and we were doing a scanning problem. And when you scan something, when you're doing a scanning problem, you need some source to scan. And we earlier looked at a problem where the scan string came as an argument to main. Okay? And because of that, and that made us appreciate what this argument to main is. It's a string of, it's a array of arguments entered by the user. Okay? And that's one place where the string to be scanned could come from. And another place is from the console. Okay? When it comes from the console, we say that's input. Okay? When it comes from an argument, it's not really input, it's a program argument. It's something that the user might have entered, so you think of that as input, but it's not console input. And when we normally talk of input, we talk of console input. Okay? And our code is very similar to the code we wrote earlier, but now we had to go, we are using some external library, and it's external, it's a library because it does some things for us. It's external because we had to do this import. Okay? It's not something that comes automatically as part of the language. Okay? The string is a class, is a library that comes part of the language. You don't have to import it. Okay? But the scanner is something that you import, and you do some magic to make to create essentially what's called an instance. And then once you've done this magic, you can take the scanner object and keep saying next line again and again, which is what we saw in class last time. I guess here you just do it once. Okay? And then now that you got the scan string, the rest of the code is the same as in the previous problem, where instead of scanning the argument, you're scanning the input. Okay, so and we are here making use of the fact that letters are ordered. So we are not using is uppercase. We are just using the fact that they are ordered in order. Okay, and just to emphasize the difference between external and internal library, if I don't put the import here, what will Eclipse tell me? Say, yeah. Okay, so this is a library package, library class, and if I omit the import, it will give me an error. Okay, and how can I fix the error? Okay, so the lazy approach. What somebody else said? So you can type in what I just typed in there. Okay, and that's the difficult thing. And the lazy approach is?
In the left-hand column, it'll put a little red mark, and then it'll suggest you.
Okay, so you'll get a little error, and if you hover over the error, it'll tell you what the error is. If you click on it, it'll go and give you ways to fix it. And in general, you can just press Control-Shift-O, and it'll automatically import all the things you haven't imported. Okay, and so that's the easiest thing to do. Okay? And so often I'm just going to give you the class name. I won't give you the whole package name, what to import, and I'm assuming that you can do Control-Shift-O to get the right thing. Okay? The problem with this command could be, I mean, if you could do Control-Shift-O, why does Java insist on an import? If the system can automatically figure out what you want, why have an import?
Extra processing that would be unnecessary.
So you're just saying making the compiler more efficient? That this way you typed it in so the compiler doesn't have to do the search? Okay, that's a good answer. Any other? Yeah?
You could create your own method or class name or something else to import.
You can create your own class called scanner. And then the question is it your class or is it the other class? Is it Chapel Hill in North Carolina or Chapel Hill in some other state? Okay? So as long as there's only one Chapel Hill, Control-Shift-O works fine. Otherwise, Control-Shift-O will tell you, okay, I found these 3 Chapel Hills. Which one do you want? Okay? So that's the reason why there is an import. Okay? So that's it. Okay, so this is sort of packages and imports, and I'm going through this quickly. And there's another chapter that discusses this in more depth. Okay? Now, the code we wrote is, and I'm using, I guess, a technical word, monolithic. And I saw in Piazza that some of you were confused as to what that meant. And why is this method monolithic? Why is this code monolithic? So there's only one class, and that class has how many methods? Exactly one method, and everything is in that method. Okay, now, usually when you see your first Java program, it's hello world. And hello world happens to, be in that one main method. So that doesn't seem like a wrong thing to do. In this case, what I wrote, is it wrong? Could I have done better? Could I have, how could I go and break? And this is the question I posed last time when we left. How could I break this into smaller pieces that make sense? Not for the sake of breaking into pieces, but that makes sense. And what criteria do we use to decide what makes sense? And, somebody posed this question in Piazza and somebody answered, what was an answer, or what is the answer possible? Yeah. Okay, so sometimes some things that you might reuse multiple times. Okay? So you can create a boombox with all the components sort of one bundle together. Or you can say, this speaker can be used with this amplifier and that amplifier, so I'm just going to make that a separate commodity, and then we can go and reuse it for different systems. Okay? And is there any other reason to make it modular? Yeah. Sorry? Group similar pieces together because... Sorry? It makes sense that way, yeah?
If you change what you want to import to take in, you can just go to that separate method and repeat that instead of having to go through your entire main method.
If you want to change something, now that you put your speaker as a separate commodity, if there's no sound, I have to just deal with the speaker perhaps. I don't have to deal with the whole piece. Okay? Okay, any other reason? Understandable, makes it more understandable and easy to read it.
You can use that in other programs.
So that's reuse. Right, good.
If you have a team working on a project, each person can start with different methods. You don't have to have one.
Right, so you can have the speaker team and you can have the amplifier team and, and they just don't have to worry about each other. As long as the interfaces, as long as the boundaries between them are well established. Okay? Okay, now that we have all these principles and reasons, can we look at this code and see how we could separate this into multiple units? And we won't go to multiple classes right now. We'll just go to multiple methods in one class, which is your task also in your assignment. Yeah.
One method to create would be separating off the declaration of the index and the loop that follows it.
So you're saying the index and the loop that follows it could go into one method? And what would you call that method? Scan. Scan, and does it just scan or does it do something else also? Right, and prints. Okay? Parsing is something that goes on top of scanning, and so that's something we'll see later. Okay? Any other ways of decomposing? I mean, that sounds pretty good to me, but I'm just wondering. Yeah.
Maybe you can make two methods, one that reads the input, and then the other one that does the data, and then just put both those methods in the main method.
Okay, that's an excellent idea. Why not go and take these two pieces, these three lines, and put that in a separate method? Okay, and then your main method just calls these two things. Okay, so I'm not going to be as good as that. Okay, but by doing this, are we gaining anything? Okay, so modularity, all that stuff is good. Are we going to increase our reuse in some way? Yeah.
Not unless it's in its own object. It's really hard. It would be hard to reuse another.
So you're saying it's hard to reuse methods unless you sort of do object-oriented programming, which we haven't done so far. Okay, let's see. So I wasn't as good as you suggested, but I certainly did the obvious thing, that I did scan and sprint, and I said, we'll have main do something, and the main just reads it in and calls scan and print. Okay, and you see the methods being called. That this particular piece of code reads something into scan string, and scan string then becomes an argument to this particular method, and this method does the rest. Okay? Now, method, decomposing a program into methods is something that I really expect you guys to know. Okay? And I assume you learned that in Comp 116, I assume you learned that in Comp 110. So we are going to be doing far more fancy decomposition later. So this much you should know. Okay. In terms of Java syntax, again, the Comp 116 students, anything funny going on here that seems mysterious? Okay, not too hard. I mean, this is pretty much how in most languages you give the method name, you give the arguments, and you give the method declaration here. And we've seen how to declare main. The declaring this particular method is also very similar. And this takes args as array of args as an argument. This takes the scan string as an argument. And this is our speaker. This just does its thing. It doesn't know how things were read in. Okay. Can you tell me? So this is the one that reads from console. This is the one that reads that scans the argument entered on the command line. How could I decompose this? Same way? Yeah.
You could separate out the error checking.
Okay, so the error checking would this part would be common, would be say in the main method or in a separate method, and this part would again be, and I would call that method. Now I already have a scan and print from the other one. Can I just reuse that one? Sorry? If you import it. Importing is relevant only when there are, multiple packages. As it turns out, I've got them all in the same package. So I don't even have to import it. How would I call that method, by the way? How would I call a method in another class? So somehow you have to tell it this class and this method. Okay? And here's how we do it. We keep this code. Again, I'm not being as good as I could have been. Okay? And I'm saying whatever my other class was, please go and call the scan and print of that. And I'm just going to pass my arg0. It's going to do the scanning. So this thing we did to understand things, to make it modular, suddenly allows us reuse also.
Successive letters
Okay.
have
So reuse is sort of the practical benefit from all of this stuff.
So, yeah.
Okay.
So
Anything mysterious here?
that arg0.
So you see the motivation from making things modular, and you see how one
R0
could
is our
go about it.
only input.
Okay.
R0, because R1, we already
Questions?
decided that there's no R1, there's no R2. And we know there is an R0.
So the dot char at
Sorry, this here, this is the package first. Then this is the state you're in. This is the city you're in.
we're gonna check
And this is the, I don't know, the building you're in.
compare the two variables.
So that was the name of the class. Just as this is called the modular uppercase printer,
What happens is the following.
a modular console reading uppercase printer. You like this name, by the way?
Right? We know we can compare.
My names are essays.
What do we need to compare cat?
So I basically need to provide somehow the class name and the method name and the arguments. Then we need some syntax, okay? But the concept is that I need the class, I need the
What it's doing
method,
is looking at the
and this is just the syntax.
input and compare.
Yeah. So this is the target of the method. Think of this as what you're invoking the method on. This is the method, these are the arguments.
One more than the int value of cat.
Okay? So even if you're not doing object-oriented programming, reuse is possible. Okay? You just have a different level of reuse with object-oriented programming.
You can think of it that way. Or you can think of them as just
Okay.
being ordered. You know? And somehow the
Okay.
comparison being made. by magic.
Yeah.
Other questions? Why do I need R0? So I have to deal with the input stream, right? Remember there's an input stream that I'm scanning. And from the input stream I'm producing a token.
So you're saying that here I've
What is my
said,
input here?
here I've called a method in a particular class.
In your problem you read from
That is not my class. You're saying this is an interesting idea. What else can I access from that class? Is that your question? Can I access the variables in that class also?
Remember what I said? I said Java class.
So
and within
what
quotes,
does
I put the
this
input string.
word public mean?
That input string that the user gave
What do you think it might mean in this context?
command prompt has to be somehow
Classes.
accessible.
It's accessible to other classes. And if I was to make a variable public,
to the string args.
which I should never do,
This is the array of arguments that the user typed in.
I would be able to access the variable also.
And we only care about one argument.
Okay, so Java lets you do
The
it,
first argument.
but this class will never let you do it.
And this is an array.
In this course,
So
imagine that
array,
that's taboo.
The zeroth element of this
And
array,
we'll get into that
is the first
maybe
argument.
even today.
that is the argument
Okay.
which is the input stream.
Other questions? Yeah.
And it remains constant throughout the loop, and then we just keep looking
You
at
know,
the
to every rule there is then,
each of this is a string, and
So,
I'm looking at this specific string.
I mean, you know,
and decomposing that code.
the Java,
First I decompose the
the
argument
guys who
into
designed Java are pretty smart guys.
First
So they must,
argument and the
since
other
they allow
argument,
this, there must be a
argument
reason.
exists, hopefully, and then I decompose.
I'm not sure. There are times when I become lazy and I say, I'm just going to make something variable public because I think of all the reasons why I shouldn't do it, and those don't apply there. But every time I've done that, I've been bitten late because I couldn't think deep enough.
So I can
So
go
if you're
back to the slide
100%
where I
sure
do the
that nothing
recording,
bad
but
will
you remember,
happen,
you remember what I
then you
typed
do
in
it.
the command
But my
prompt?
recommendation is just never
Java,
do it. At least in this class,
class name,
don't do it.
and then John F. Kennedy. Do you remember seeing the word
Okay,
John F.
other
Kennedy
questions?
somewhere throughout the class?
Okay, so I have, through this problem, told you more or less all the things you need to do your assignment. And the one thing I haven't talked about, which was in the class material I put in the assignment, is the substring thing. So what is the substring method? In general, I'm showing it being used here. So in general, the substring method does what in English? Yeah.
We're able to extract indexes of the string and then make arguments or
So from a string, you're able to create chunks of it, right? Chunks of contiguous characters. Okay? And so the first argument is the Sorry? Start point. And the next argument, I can never remember that, is the end point, which means what? Which means the last index of the last character to be gotten, or the index beyond that? Index beyond that. So what will hello world substring 47 give you? So we start counting 0, 1, 2, 3, we get O, 4, 5, 6, do we get R? Okay. 4, 4 will give you what? This is the index of the last character to be gotten, or the character after the last one? So it will be a string of length, and it will be the null value. It's a string. It's a null string. It's not the same as a null value. It's a string with nothing in it. It's a string with 0 characters in it. Okay? And 7, 4 will give you what? Okay, begin index and end index. So basically you get all the characters from begin index to end index minus 1. So this is going to give you this. This is going to give you nothing. Okay, just between quotes nothing. Okay, it's a null string. And this is going to give you an error. And errors in Java are called exceptions. Okay? Okay,
emphasizing strings here.
there was a question in
Because
Piazza,
your first
how can I
assignment is all about
append
strings.
to a string?
And
I assume
need
you
to
guys
know
were
certain
thinking
things.
that, okay, I'll go to one character, then I'll go to another character, I'll append that to the
And
string, and
anybody
so
wanna
forth.
guess what this
You don't
exactly
need
does?
append. I didn't tell you about append. You don't need a concat. You can just get the chunk you need. You just have to figure out, here's the index, start index,
Return
here's the
for a
end
string.
index,
That's what the
and then you
language
get
substrings
all of
seems
the
to
characters
indicate.
in one chunk. You have to go and build the chunks
the
up.
part
okay?
is defined
So
by
I didn't
the
tell
two
you about it, and you don't need it.
arguments.
Okay?
And the
Questions
question
about
always
this?
here, which
I
I
know
can
there
never
were some
remember,
people,
is that
Some people
is it
either didn't know
including
about
an
this
index?
or didn't know how to
and
use
begin
it.
index,
Okay, if you don't know how
or
to
is it
use it,
not
that's
included?
another issue. That's where you need to sort of hone your programming skills.
I can't remember.
But at least you know what it
So
is.
hello
Okay,
world
that's how you can
substring
get
47 will give you
tokens
what?
of more than one character.
How do you
Questions?
count, by the way? Do you count starting at? Okay, you normally.
And another thing you have to do is convert a string into an int. Okay? And I told you how to do it. Okay? And now can you guys figure out what this integer.parseInt is? Can you break this syntax up? It was magic for you, right? You just typed in integer.parseInt and you did that. But what is integer here? And this is a... So you've been using this actually. Okay? And it was just magic to you, now you know what the syntax is like. And what do you think I'm doing around it? I made things more complicated than you need to do it. Just by example, without giving into depth, what's going on here? What's this try? What's this catch?
It's a block where an exception might happen. So you try and the exception occurs, you have to check.
Okay. So the whole idea is you're saying, you can do things confidently or you can do things tentatively. Okay? And when you know things will work just fine, you say, okay, I'm going gung-ho, I'm very confident. And when you're just tentative, you say, I'm going to try. So if I say, can you do the extra credit? You can say, of course. Or you can say, I'll try. Okay? And try means I might fail. And I might fail not because of something bad I'm doing, but because of something bad I might have got. So this read int is doing scanner.nextLine. Who knows whether the next line is something that can be converted into an integer or not? We don't know that. So one thing is to just throw up your hands and say, oh, the instructor says no errors can occur, so, I don't have to worry about it. Okay? Or say, I will catch the error. My own code will catch the error and will do something in response to it. And the typical thing people do, and we'll get into exceptions in much more depth later, but I just want to show you this code because just to give you an idea what's to come, and you can't really do much programming in Java without knowing something about exceptions. Okay? So that's what's really going on, that if this code succeeds properly, then this code will not be executed, the one in the catch block. Otherwise, the catch block will be executed, and you're just going and printing out the stack trace, where I am in the code. And you can also print out, instead of doing that, or in addition to doing that, you can print out the exception, such as null pointer exception. And so this is what the JVM essentially does. If you don't catch the exception, it'll go and print these things out for you. Okay? And you can see why I keep getting confused in read line and read string, because my own class console has this read string method as opposed to read int, and which does the next line. Okay? So, and if there's some problem with the next line, I'm going to just again, and notice that I'm returning a value. Okay, so if I have an error, I don't just, I catch the exception, but this particular function still needs a value, so I'm returning 0, and in this case, I'm returning the null value. Okay, so I'm doing some kind of error recovery. And you don't have to do any of this stuff right now, but I'm just giving you a preview so that you understand to some extent what's happening when exceptions get thrown in. Okay? In terms of understanding this example, not the concept, any questions? Okay. Now that I have this console class, how could I use this console class? Is this a useful class for you to use, by the way? Because you can do the read int, read string. And is this method useful for you also, read string? You have a next line. What does this add to next line? This class. You don't have to instantiate the scanner. Okay, that's done for you. So here I'm showing you this being used. I can just say console.read. I wish Java had just done that.
So loops, that's a
okay,
while
so
loop.
I don't have to explain to you what
loops.
Instantiation is the very first day of class to do
we
input.
see code here that
Just say, here's a console class. Just do a read string from that, or read int from that, and you get the
You
int.
see how you can
You
comment?
don't have to go and say new
within a
scanner,
line,
new
say,
buffer input stream,
standard
all that
languages, I
stuff
think
that you
now.
have to say in a long-winded way.
So what's happening here?
So now this is the class that we formed, and I'm going to reuse it here. Okay. So what am I doing? I'm saying, I'm going to now, there's some more reading here. It's a little different reading from what you do in your assignment. How is this different? Can you figure out from this code how what I'm reading is different from what you guys are reading? Yeah. So the user we know how many strings are going to come. We don't have to wait for a dot or a dot followed by a number, who knows what, right? And I'm going to, what am I, and that input, what am I doing with that, with the string that I read?
How many elements do you have?
Sorry?
And that number is read in a variable called num elements. That num element.
So I'm getting, I'm reading it as an integer. Okay, that's one thing I'm doing.
Dynamic array.
And
that's kind of the exclamation mark form.
And that is the number of strings. And then I go and read those many elements.
But I didn't grow up with dynamic.
And this read string, what am I doing with it?
Languages I used, the array size was fixed at program writing time.
Storing it in an array.
Okay, but in Java,
okay, a lot of you guys were saying, oh, can we
array.
use arrays or array lists,
Depends on
which is
something
something
you
more fancy. And I said, yes, if it
then
makes
what it
your code
does
more
is it says, okay,
modern.
you
Okay?
said
And one of the things you might want to do is just
enter
read a
so
bunch of
many
input
things, you better
and
enter so many
give it to some other
numbers,
method as an array.
And it goes through the loop
Which is what this is.
reads all of those and puts
Okay, I'm not doing another method.
So
but I put this in an array.
This is an array of strings.
And by the way, what does this dynamic array mean here?
And the name indicates strings. And you say new, what type, and how many elements you have. And then you can access an array element just as you can access an array element in any language. Okay.
So it's a little louder. You said the users can update the array?
Square bracket? Maybe not. Maybe Fortran it was curly, it was for instance. But that's pretty much the syntax. And
so the size of the array was fixed at runtime.
Similar code, except
it wasn't fixed when the program was written.
Element in the array.
That's a big deal for me because the first languages I learned, all the arrays were fixed at program.
Now look at this code here.
This is nice.
Here?
You can read an input variable from the user and then allocate an array that. Okay? That's what dynamic array is. But once an array is created, its size can't change. Okay? If you want to simulate something whose size can change, you use
Raise your hands again.
either you create your own object, which we'll see, or you use an array list or a vector. Okay? And this particular piece of code prints the array input in the previous loop. Okay? No mysteries here, except I'm using a for loop. Now you guys see how a for loop works. Okay? You see two examples of for loops
First,
where you initialize the variable is
string
declared
that
in
was
the
entered.
in the loop
And that
itself,
string is breaking it
and
up.
this tells you when you should terminate the
Breaking it
loop, and this
up.
tells you what to do after each iteration.
Breaking it up in individual
Just if you use
characters,
any form of
and
for,
printing each
even in Comp 116, you can probably understand what
Now,
this is.
I say this is unsafe. Why is it unsafe?
So you don't have to just use while loops, you can use for loops. Okay, that was allowed. And what am I doing here?
Memory is inefficient. If it
So
takes more
strings
memory,
is the
inefficient,
array I
it's
filled
inefficient,
in.
Not unsafe.
And it's an array of
You were
strings.
saying
So what am I doing here? Printing all the strings I read, or the
I'm talking of this particular thing. Why
First
is
one.
this unsafe?
and I'm printing out each what in the string.
If the user enters
character.
num elements of 0,
Okay. So I've
I'm
got
not
an array of
entering
strings. A string itself you can think of
that loop
is
would have
of
never been
it being
executed.
an array.
And you
of,
go
of
and say,
characters.
give me the
It's not
0th
an array,
element,
it's a
and there is
string.
no 0th element.
And I'm printing out. And why do I say this is unsafe?
You're going to get all kinds of errors. It's subscript error.
Yeah.
So, but let's assume, so I put a little comment saying
The user might have said
I
0,
trust my users to put
in which case we read no string, and then my code is going to bomb.
Now,
I'm going to have an
look at the
exception.
syntax here and look at the
Okay.
syntax.
So you're seeing here how to use
And
for
you expect
loops.
some similarity
You're
in
seeing
the
here
syntax. But they're different.
comments.
So,
how to do
Let
comments.
me ask a more fundamental question. What is the
And
difference
the
between
concept of
string
comment I assume you know from earlier.
and an array?
Okay. Now you just see the syntax difference. When you have an array, you just go and put a subscript there. When you have a string, you say char at.
So
Okay.
an array
So this is non-uniform.
is-
I mean, the
is
concept
the
is that you're
sequence
getting the ith
of
index.
value
Okay.
of the same.
But the syntax is different, and the syntax is different because
is a sequence of.
I kind of have the answer here, but you want to say it in your own words.
So then, why not just declare a string to be an array of characters?
Different people wrote it, and they weren't talking to each other. That's a good answer. That's a good answer actually. It's happened in Java, but this part came from
But a
one
string
guy.
in Java
Both these parts came from
is
one.
something that's built on top of an array. I talked about a library and Java
So,
and library.
One of
The
these
assignment
things
statement
is
is part of the language.
part of the language.
The fact that
really part of the
Gosling,
language.
who invented Java, said
So
it
it's
could
got
be
when you have something that's part of some type that's
what
part of
he-
the language,
that's
there's special
what he
syntax.
invented. He was based on C,
And
he
one
liked
of
C,
these
and he put C.
is something you can layer on top. You can replace with your
The
own
fact that strings are the way they are
type.
is
So
because
which is built into the language, which is
he
replaceable.
put a library. He used the language to create.
Which seems to be more standard
Use
syntax.
in other programs. That's what a library is.
Array is a standard because intuitive. But in terms of if you were to replace things,
Much more freedom. You can say,
when you replace types with your own types, which syntax do you think those types are going to follow?
And you're like God. You're gonna make it. In the
So
library, you sort of take what-
char at, dot char at, is a lot like dot.
So this
Parse
strings are
int,
built
right?
on top of the language.
It's
On
a
top of the
very
language, you can't play
extendable
on the
syntax. You
can't
give
invent syntax.
the target, you give
Whereas
dot,
for
you give the
arrays, you
method
can invent
name,
special syntax.
and that's a syntax.
Okay?
The target could be a
So,
class, it could be something called an
Here you
object.
say
So that's more
string dot
extendable.
length, no parentheses.
The array is more intuitive,
Yes,
it's part of the
because this is
language,
Gosling. He can do whatever he
and
wants
it's
to.
built in, and there's
Arrays,
special
he can
mechanisms
put
for
with
it.
parentheses, without
So arrays
Here
are
I
built
say
into the
with
library.
parentheses,
Strings are a library that can replace with your own objects.
And methods
They're
to
still
call
part of
this
the
string.
language library
If I
that
want
comes
to
with
add
the language.
operations
So it's
on a
still
string,
confusing. You don't have to
I
import
add them
it.
through
But it's
methods.
not
And
got
methods have a
some
certain
special
syntax.
syntax for it.
Whereas this is
Okay?
just
And that's the reason why things are different. The idea is that you could define your own string
so
class.
you see that, and it's very
The string was
confusing.
built on top of, there's a layer underneath. On top of that, the strings got built,
Size here
and that is the
there,
reason
you
why
know, you
strings have a
to
special
these-
different syntax.
Okay. Here you say string,
Questions?
square bracket, and so forth.
Yeah.
Because again, your language. Here you say x dot charac. Again, you have to call a method in it.
Sorry, slowly. If you remove which
Method
for?
has
This
to
for?
have a certain syntax. So that's if you're. So there are 2 points I want to make.
Sorry, this
Firstly,
for?
strings have different syntax from regular arrays. Okay. And
Third
more
for?
fundamentally, strings are built on top of the language. When you build on top of the language, there are certain constraints that you have to follow. and strings follow those constraints.
No, that's
And
valid.
when later
I
in
can say
classes
s dot
with your
char add,
objects,
then have to give some
in your
some
classes,
value
you
here,
have the same constraint.
and this variable I got declared here. Okay. Questions? You can say print string, but here I want to print everything
So
as a
arrays
character. Each
within
character is in a
language,
separate line.
Strings are like.
I just want to show you the syntax for doing that. Okay.
And you see the difference, element number here.
Now, can I break this piece?
and
Can I convert this
highlighting what
this
it says.
code into? Can I make it more Can I make it more modular? I could put this whole this code into one main method, and it'll be a monolithic main method. Again, to get practice with creating modular code. Could I break this up? And is there some hint being given to you already? Yeah.
You've taken the length as a parameter, so the length, if you want it to be 0, or use 0 and just put 0 character.
Okay, so you can make this more flexible by just going and saying which element do you want to print. That's one thing, and you can make that a method. But if I don't want to even have this flexibility, I just want the same code with the same functionality, more modular. Am I getting a hint from this picture as to how I might break it up? Have I broken it up visually in some ways? And my comments are telling me also, this part does this thing. This part does this thing. This part does this thing. And, I can feel very good. Oh, I'm commenting. My instructor will love me. I won't. I'll say, you're commenting. You're doing something really bad. Because, if you're writing bad code, sure, comment bad code. But the fact that you're commenting this particular piece of code means that you're actually writing bad code. Because I could replace comments with method names. And my method names, if they're essays, like my method names are, then you know what they're doing. Okay? So, comments versus program decomposition. And I'm being a little heretical here when I say comments are bad. Comments are good when the code is bad, but it's better to have good code which doesn't need that many comments. Okay? Despite your best efforts, you will write code that is not as simple to understand as it should be, then you comment. Okay? But the fact that you have to comment sometimes is a symptom that your code could be more modular. Okay? So the first choice is self-explaining code. And the second choice is bad code with explanations. Okay? And kind of the analogy I'm thinking of right now is, a Shakespearean play versus just a nice New York Times article. Okay? For a Shakespearean play, you might have a lot of New York Times articles explaining what the guy really meant. Right? Or if you have a poem that's trying to use few words in a very lovely, elegant way, you might need some prose to understand what the person's really saying. Okay? Whereas if you have just nice prose, then it's self-explanatory. And we're not trying to write poetry here. We are trying to write good prose. Okay? So I can have a modular read and print strings, okay, which just goes and so this is the main method. Rather than the main method, this is the main task where I'm going to read. I'm going to have so let's try to understand what I'm doing here. Read num strings will be a method that does what? That the first thing that the user types in. Okay? It'll return a value which I'll go and pass to read strings, which will know how many values to read. So it's going to have that loop that goes in, fills up the array, and it's going to return an array. Okay? Then I'm going to say print strings, I'm going to pass it that array, and then I'm going to say print string, and I've got what you wanted. I'm saying strings of 0, I can say strings of 1, strings of 2, strings of 3. Okay? I don't need any comments now, I don't think so. With these long names, yeah?
Is there a typo in the public side?
Yes, there is. There's this extra this thing here. All this code actually works, more or less. The trouble is that when I take from Eclipse and copy it here, I have to reformat it. So sometimes I'm very lazy. I just go and change the PowerPoint when I change the code. Okay? So yes, thank you. And so now here's my read strings. It's self-contained. It says, please print the number of strings. I can change the prompt. And it does, and it uses console.readInt. I don't have to instantiate the scanner. I don't even have to know about instantiation here. And here's my read strings. And so comment is being replaced by a long identifier name. Okay? Your rubric is going to change so that at least 10 points are for good names and other coding conventions. Okay, so we'll talk about case conventions after this. And if you have bad names and comments, that's okay. But that's not as okay, but it's better than having bad names and no comments. Okay? And, I'm such a bad typist that the last thing I should be doing is having these long names. Okay? I mean, you saw, whenever I try to type, I make a mistake, actually. I'm not a touch typist. And so, but Eclipse comes to our help. I can go and, once I've gone and said read and print strings, I can just say RE and then say control space. And if there's no other variable with that prefix, it'll just complete it for me. Okay? So just get used to this. And if you really don't like this also, have your lousy names and then do a global substitution later. Okay? Or you can refactor also in Eclipse and call it something different. So yes, long names take time to enter, but there are ways around it. Okay? And personally, if you ever seen any, if you've seen some business talks, there are a lot of acronyms there, a lot of buzzwords, where they'll go and have these acronyms that people don't know anything about. And acronyms I've never liked in talks, I don't like in programs, because you forget. I mean, why should I be thinking about what you really meant by these 4 letters? I should be thinking about what the message you're giving me is. Okay? So, it's not the comments are not useful. I mean, this fact that this is unsafe is a good comment. Okay? So I'm not saying don't comment at all, but I'm saying try as a first choice to use good names. Okay? This is your print string, this is your print string. So print strings prints out this array, and print string prints out one particular element. Okay? So what to write in a comment? Is this a good declaration? No, right? I mean, you shouldn't use W. W could mean anything. But if you're going to use W, might as well comment. Is this a good example? You're commenting for the sake of commenting. Okay? Redundant. I don't need it. Wait. Okay? And is this a good comment? We always said yes. Okay? So it's not that comments are bad, but often you can get rid of them. Okay? In addition to comments, we're going to have some case conventions that Java has, and I'll require you to use it also. And anybody know what some Java case conventions? Yeah. Sorry? What case? And what is the word you use for that? Camel. That's a new word. Oh, really? C-A-M-E-L? Wow. I learned. Mixed case is what I'd say. I don't know. I had long-winded ways of explaining that. Okay? So variable name should begin with the lowercase letter. Other conventions that you might have implicitly seen? Yeah. Class names start with an uppercase letter. Okay? And in C#, in method names, lowercase. In C# they use uppercase. So it's not as if this is sacred, It's just that this is what Java does. So start class name with uppercase letters. So which is the one you want to have? Okay. Start variable and method names with lowercase letters. Okay. And so this is my long way of describing what you guys said succinctly. So which is the correct thing to do here? Okay. So that's something you should be doing. Any other questions about style? You guys can all get the 10 points for style in your program? Okay. Sorry, say a little louder. Small variables, meaning small. Okay, so in for loop, can I use I or not? If I wasn't to use I, what would I use? Index. And is anybody going to be confused if you use I? Where do you think this I came from? I for index? J. Why is J used as a... Sorry? MATLAB. So there was a language. That was my first programming language because I'm an engineer. Anybody guess what an engineer learns as a first language? No, that is computer scientist language. I learned Fortran. Okay? And in Fortran, the type of a variable was not declared explicitly, from what I remember. It's been a long time. And I, J, K, L, M were all integers, and anything else was doubles. Okay? And so this is where the tradition comes from. And you want to use I for loops, go ahead and use it. But I recommend you use index. It just makes things more clear. But you want to use I, J, K for loop indices, that's okay. Okay. I've told you Java sort of by example. And there's more formal definitions possible. Okay, and my own notes for 110 provide you with that. And we're going to look at some of these concepts in more depth later, like exceptions.